These are the 2.1b notes. This is all about operations on functions. So today we are going to add, subtract, and multiply functions, as well as do something called composition. So we'll first start with adding. They're going to give you two equations for this one. Here's your f of x and your g of x. And the f of x and the g of x is pretty much just naming those equations, those expressions. So if we are going to add, we just need to combine like terms. This f plus g of x is the same as writing f of x plus g of x. You might see that. You're just going to take each of your functions, 2x minus 7, put in a parenthesis, add it to the g of x function, 8x plus 3. And then you just add like terms. 2x and 8x makes 10x. Negative 7 and positive 3 makes negative 4. For part B, you have a subtraction problem. I highly recommend distributing the negative. This problem you might also see as written as f of x minus g of x. That means the exact same thing. And we're going to plug in our functions. Because I'm subtracting, I'm going to distribute my negative, which essentially means putting a negative 1 here and distributing that out. That gives me 2x minus 7 plus negative 8x minus 3. It's not a requirement, but it does make sure that you get the negative on that 3, on that last number at the end. That's one that people tend to miss. After that, you combine like terms. Negative 6x minus 10. For part C, that's a multiplication symbol. Again, you could see it written as f of x times g of x. That means the same exact thing. And for multiplying, you are probably going to either distribute or FOIL. So we'll write down our two equations, our two functions. And then this turns into a foiling problem. If you remember how to FOIL, go ahead. Oops. All right, so those are the four things I get when I distribute, FOIL. And then I'm just going to combine my two like terms in the middle. 6x and negative 56x makes negative 50x. So our last one, notice this open circle here. It's not the same as multiplication. That's actually composition. So composition over here on the left is when you have that little open circle. And that means you are going to plug in one function to another. Another way to say it, you substitute it in for the x. So this is similar to substitution when we did it back in substitution and elimination during algebra. You're just going to replace the x with the other function. This one's helpful when I color code, so I'll go ahead and do that. I'm going to have one of them, this first function here. Let's see, I'll have this one be purple. And this other one can be this maroon color. And when I see this f of g of x, another way to write it, you'll often see it written as f of g of x, just inside parentheses. So you're going to start by taking your g of x, that 8x plus 3, put it inside a parenthesis, and then that's going to go in place of the x in the purple equation. So 2, what would have been x, minus 7. So g of x is literally getting substituted into the f. So you could even draw an arrow here. This is going into that x right there. Once you have it set up, the rest of it's pretty simple. You're just going to distribute, combine like terms. There we go. Let's practice that composition a little bit more. So look down at example number 2. You have 2 new functions. Now your f and g are different than they were on example 1. So for part A, we can also write it as g of f of x. And f is going to go into g. So you could do a little arrow like that. You could write a little note, f into g. You could even circle the f and draw an arrow to the g. When you plug it in, it's going to look like this. Then you distribute. And combine like terms. We're going to use those same 2 functions. Switch to purple here. We're going to use those same 2 functions, except we're going to kind of plug them in the opposite direction. This means f of g of x. So notice how the g is inside the parentheses of the f. So g is going to go inside f. G will go in for that x. See if you can write it. Replace this x right here with a 3x minus 4. Should have gotten 5. Plug in the 3x minus 4 squared plus 2. All right. Once that's set up, then you're going to just follow your basic math rules. It says I need to do parentheses first. There's nothing to do with the parentheses. I can't subtract the 3x minus 4. The next step is my exponents. So I need to take 3x minus 4 squared, which means I need to write it twice and FOIL. So I'm going to kind of take that off to the side and do it. So that's kind of what I got when I FOIL that off to the side. So I'll just take that answer, 9x squared minus 24x plus 16, and I'll just replace it with this little piece right here because that's what we solved for. So 5 times, and then the plus 2 at the end. You could have done all that within the problem if you wanted to. I find it easier to do it separately. From here, we'll distribute. And bring down the 2 at the end. And then you've got your like terms, your integer numbers at the end. You can add those together. Everything else just copies down. And here's your final answer. So based on what the setup of the problem is, once you get the f into the g and the g into the f, it might be a pretty short problem. It might be a pretty long problem. On the back side, we're going to talk about the same thing, composition, but with numbers this time. So this is actually easier to do with numbers, just because numbers are easier to work with than variables. So we're going to do f of x and g of x. They give us two new functions. I can also write this as f of g of 1. And I'm just going to kind of work backwards. I'm going to plug 1 into the g function. So this is my g function. I'm going to multiply 4 times 1, and I get 4. Then I'm going to actually take that answer and plug it into the f function. So 4 was my answer. I'm going to plug it into my f function right here. 2 times 4 squared minus 3. Two times 16, 32 minus 3, and that gets me 29. All right. Without having to write all this extra stuff, let's see what we can do. I'm going to do 5 into f. Plug 5 into f. So 2, 5 squared minus 3. So that is the 5 being plugged into the f function. 5 squared, 25. That's 50 minus 3. It's 47. Once you get that answer, you plug the answer into g. So it's almost like you're double plugging it in. So you're going to plug 47 into the x. 4 times 47. And you just multiply. 188. For example number 4, they actually give us 3 functions here. It doesn't change what we do. It's just giving us more options on what they can ask of us. All right, so part A. Take 2, plug it into h. Into h. That gets me 8. Then take that answer 8, plug it into f. (40 minus 1, 39). All right, see if you can set up the next one. Start by plugging negative 3 into f. You get negative 16, and then you're going to plug negative 16 into g. So that negative in front, and then you plug in the negative 16, which gets you an answer of positive 16. For our graphs, we have 3 different graphs here. We're going to do this very similar to how we did it at the top. Notice the notation is a little bit different. It means exactly the same thing. So we're going to look at the F graph first, right here. Change colors. So for our F graph right here, we're going to find the number 1 for our X. That's right here. And I'm going to look up and say, okay, what is 1 paired up with? 1 is paired up with 4. So my first answer is 4. So instead of having to plug it into the equation and get an answer, you just look for the x value up here, pair it up with a y value, and that is your answer. Then we have to do the h part. So then we look at the h. I go to where my h graph is 4 here, and then I write down the 3. That's my final answer. Let's try that again. On the next one, I'm looking for g of 2. So go to your g graph. Find where your x is 2, right here. What number is it paired up with? It's paired with a 0. Then switch over to your h graph. H is over here. You want to find where x is 0, and you write down your y value. Next problem. F of 2. See if you can try this one. I'll give you just a moment. That one should get you an answer of 0. So f of 2 here got you 2, and then 2 linked you to 0. Try the last one. All right, the final answer should give you a 4. So 3 linked to 3 right over here. And then I brought that 3 over, looked for where 3 is the x and what is the y value. That would be 4. All right, really nice job today. If you have questions, let me know.